Airing here. So I got a couple housekeeping things just real quick. We've got swag on the table here, so everybody grab something before you go. Bathrooms are out this back door here. And I think everybody's signed in and got a name tag. Trash can back here in the back if you need it. So I just want to give you a quick introduction to Kingsman. Thank you for coming out. Welcome to our shop. We are a software as a service company. We pride ourselves on delivering high quality software. And one of the things that we do to achieve that goal is we invest in our people, and through giving opportunities for continual learning and improvement. And tonight is one of those opportunities. We're going to let one of our team leads come up and share what he has learned about GraphQL with everybody. And with that, I'm going to turn it over to Austin.
Cool. All right, so once again, just wanted to say thank you everyone for coming out today for the Tech Talk. I'm going to be going over some pretty cool stuff that we've been working on here lately at Kingsman, specifically around using GraphQL in a more C# friendly environment with HotChocolate and Dapper. So to kick us off, I'm going to start off with our agenda for today. As you can see, got us broken off into 6 parts. We're going to actually have a live demo at the end, so you'll get to see what GraphQL queries and mutations look like, and you'll kind of get to see how things differ between probably a standard REST approach, which might be what most engineers are more familiar with. So to start off, we're going to have to go back in time a little bit to 2014. So Facebook, when they were starting off their mobile development, specifically around the newsfeed section, they were experiencing a lot of problems around overfetching data. The newsfeed sections that they were pulling back contained a lot more than they really needed to work with. And this was causing a lot of issues on their end. And they were also, they were having trouble with the data they were requesting was different than the data that was coming back. So they knew they had a problem. So the Facebook engineers got together and they started thinking of a better way to do things. And that is actually where GraphQL came in. So what came from their talks and their discussions was they knew that they needed a new way to handle data retrieval, specifically something that could eliminate the problems they were facing with typical REST APIs around overfetching and underfetching data. Some of the big benefits of GraphQL is that it actually has a single endpoint for data access, whereas if anyone who's worked with typical REST API, you're writing endpoints for just about anything you're doing with data retrieval, right? So some key GraphQL terms that we're going to discuss today are going to be schema, type, query, mutations, and resolvers. So query mutations are going to be familiar to most people who have worked with REST APIs before. These are going to be your actual read and write operations. A schema is going to actually describe to you when you're trying to consume a GraphQL API, it's going to describe to you what you can actually access through that GraphQL API. So the first key concept we're going to talk about is going to be what is a GraphQL schema. So if you look over here on the right, we have a sample snippet of what a GraphQL schema looks like. So at the top here, we have one of the topics we're going to discuss today, which is the query type. We also have down here the mutation type, and below this, you'll see what is known as an object type. So what's really, really cool about a schema is a schema will actually let you know when you're trying to consume the GraphQL API, what you have access to. So you'll actually know what you can send in and what you're going to receive back. So that's going to lead us to our next thing, which is what is a GraphQL type? So a GraphQL type are essentially just fields that are populated from your backend data stores. So what that means is if you look over here at the top on the example object type, you'll notice we have a type user that implements an entity. So this type user at the top is what's known as an object type. So an object type is essentially just a collection of fields that in turn have their own type. So as you can see, a common theme with GraphQL is everything has a type. So if we look over here at our example object type, you'll see you have a type user, and you'll also see that you have a ID column that takes a unique identifier. So the unique identifier would be considered a type, isActive would be considered a type with Boolean, and then createDateTime would be considered a datetime type, right? Down at the bottom, we have what's known as an abstract type. So an abstract type would be something that can actually be implemented on an object type. If you're familiar with general object-oriented programming, this would be very, very similar to a class that inherits from something else, right? So down here at the bottom, you'll see we have an interface of type entity that is then implemented on the actual user type. We'll go over here shortly the really cool things that this allows you to actually do with GraphQL. So we're moving on to our next topic, which is what is a GraphQL query? So as you can see, this is a smaller snippet of the original schema that we saw earlier. And you'll see that we have two query types on here for an entity get all and an entity get by ID. So what this lets you know, if you're trying to consume this GraphQL API, this lets you know that if you were trying to request data for a read operation, you would have access to both a get all call and also a get by ID call. Now, what's important to note here is that on the get entity get all, you see that it returns back an array of type entity. So if you saw on our prior slide, entity is actually the abstract type. So by having a get all operation that returns back type entity, you're able to actually add some generic actions to your read operations. So by returning type entity, anything that implements the abstract type can be requested from this get all operation. Now, when we actually get to the live demo, you're going to see how powerful that really is. On our entity get by ID, by seeing that it's clearly defined that you would pass in an input of UUID, that lets you know that when you're trying to request by ID, it would want you to pass in a unique identifier in order to retrieve back a single entity value. Another really important thing to note on our example snippet is the exclamation operator at the very end designates that the return type is non-nullable. Now, this is very important because with GraphQL, you can specify whether you want something to be required or not required. So if you see your schema and you see that it's designated with this operator, that lets you know that if you're writing a query against this API, you're going to have to pass in a value for that, right? So now you're probably wondering, what does a structured query actually look like for GraphQL? So as you can see up here at the top on our example query, the designated term for query up here at the top, followed by what our actual type was, which was the entity get all. And then you see an unfamiliar thing for ... on user. So what this actually is this is known as a GraphQL fragment. So what GraphQL fragments do is any object type that implements an abstract type can be requested from your entity get all. So the ... on user is actually you designating that you're wanting to call the entity get all read operation and return back type user. And that's a very, very powerful tool, because if you had several object types that implement the entity type, you could request any of those types that you wanted to, and then return them back with a generic operation such as entity get all. So instead of having to write a very, very specific, get user, get employee, whatever you were writing for, you're able to just designate a single interface and then implement it on all of your object types to return them back on your get all. So you can see here, you have your on user, which lets you know, the object type you're trying to return back. And you also have ID and username. So that lets you know that you're trying to return back type user, and you're specifically looking for the ID and username fields. So next, we're going to move on to what is a GraphQL mutation. So this is another snippet from the schema that we saw earlier. So we have our type mutation up here at the top. And this lets us know that we have available to us two operations for writing information. That would be our add user and also our add users. And the big thing to note here is if you look at the input for this, you'll notice that the add user has just a single input. And the second one for add users has braces around the add user input. So what this would tell you, if you're looking at the schema, this would let you know that you would be you'd be passing through an array of the add user types instead of just requesting a single, or instead of just adding a single user for your GraphQL mutation. The piece after here, the add user payload, this designates what you're actually returning back from your mutation. So you're passing in the user you want to input, and then you're receiving back a payload of some type. Now, you don't see this here, but on your actual schema, and you'll be able to see this when we go over the demo later, the add user payload will actually be on your schema, and you can go into that and you'll know exactly what you can expect back from an add user payload and exactly what you need to pass through on an add user input. So now we're wondering, what does it look like to actually structure a GraphQL mutation? So at the top here, we have our new user that we're implementing. They really, really love Kingsman, and all we have to do is pass through the username. Now, if you look down here at the input, you'll notice that we have both a username and also a user type _ID. Now, the reason on our mutation that we only have to pass through an actual username is due to our designator for the exclamation mark here. So if you noticed earlier when we were talking about nullable versus non-nullable, having the exclamation mark here on username lets you know that that's a required field, but user type ID is not a required field. So this lets us know if we ever want to add a user, the only thing we actually have to pass through would be the username value. We do not have to pass through a user type ID. And this is very important to know because when we were looking at earlier slides, one of the big issues they were having with typical REST APIs is they didn't actually know what they needed to give through in order to get the shape of data. They didn't know what their shape of data was. So this clearly designates to you exactly what you need to pass through and what you can expect back. So now that we've gone over some of the cool parts about GraphQL, it's time to talk about things that might make you not want to use GraphQL. So GraphQL is very, very powerful in mobile development, specifically around any sort of application where bandwidth usage matters. The ability to never overfetch or underfetch makes it a very, very good tool for any application where you're going to have to possibly be used in a mobile development or anything like you said, with where bandwidth usage matters. The next one is going to be when you're actually developing anything related with microservices, you can actually define a separate schema on each microservice and then use something called schema stitching to basically piece all of those schemas together. And then the actual stitched together schema will be what your client will be able to actually see and consume. What's nice about this is you know exactly what to request, but you can manage it with all your separate microservices. It's a very, very powerful way to handle data retrieval. So some common reasons to not use GraphQL. One of the big things you'll find if you actually research GraphQL online is a lot of people try to, they'll either try to compare it as like a REST API killer, or they'll try to act like it's the latest, greatest thing to ever come out. It's really not meant to be that. It's more so meant to exist side by side with REST APIs. Just like anything, what choice you use for data retrieval is always going to come down to what your business needs are and whether or not the application that you're developing should utilize. The next thing is if you are expecting GraphQL to solve all of your performance issues straight out of the box, you definitely need to take a step back and sort of reevaluate what your approach is. GraphQL is very powerful, but it is also limited to the actual implementation. It suffers from bottlenecks. It suffers from all sorts of things. And if you're not actually taking the time to identify those bottlenecks and optimize your performance, you will run into the exact same issues that you might be currently experiencing with a REST API. So before we actually continue with that, does anyone have any questions they'd like to ask about GraphQL in particular before we move on to a Dapper overview?
Yes, so does GraphQL have any specific name for handling?
Yeah, so for those on the call, they just asked if GraphQL had any particular things for error handling. It actually does, but you would implement that on HotChocolate, which is going to be your actual client that consumes the queries that come in. So whenever we get to that, I'll go ahead and showcase that for you. Anything else? Cool. So we will move over into what is Dapper. So has anyone actually worked in a C# environment where you've used Entity Framework? Okay, so Entity Framework solves a lot of problems out of the box, but generally Dapper is paired pretty much next to Entity in a lot of situations. Is there familiarity with Dapper for the most part? Never used it? It's great, you got to try it. So the best part about Dapper is it's out of the box. It doesn't offer much. It offers the bare minimum of an ORM, but Dapper gives you the ability to actually pretty much manually create what you want your SQL statements to be. So that works very, very well with GraphQL, because with GraphQL, we're trying to never overfetch or underfetch. So Dapper actually gives us the ability to craft our SQL statements. Any framework out of the box is nice because you're able to just put a dot include on everything. But with Dapper, you can actually handcraft these SQL statements to only grab the columns or tables that you truly want to grab from. So the next slide we're going to go over is what is HotChocolate, right? So HotChocolate is, they have some pretty funny logos, but HotChocolate is actually part of the Chili Cream platform. And what they seek to do is they're trying to actually make a GraphQL client outside of, there's a couple others you can use. There's one that's GraphQL.net that is if you read online, a lot of people will tell you that GraphQL.net works fairly well, but HotChocolate has a lot of support behind it. They have a high frequency of updates, and they also have a pretty substantial product library, and they're regularly coming out with updates. So Banana Cake Pop is actually the IDE that they use for you to run GraphQL queries or mutations against your GraphQL client. Strawberry Shake is another one that they've recently come out with, which actually generates custom .NET clients for you that you can use with your GraphQL clients as well. So we'll go into what actually is a query in HotChocolate. So if you see over here in our code snippet, the iResolver context up here is pretty much the bread and butter of anything to do with queries with HotChocolate. So what the iResolver context actually lets us do is it takes our GraphQL query and actually breaks it down into a tree structure. So if you remember in the earlier slide when we were talking about the query, you'll actually have your data will come in, and when you saw the GraphQL fragment, which was the on user, your top level will be user, and then whatever fields you passed in after that will then be broken down into a tree structure. So on our get all, we had an ID and we had a username coming in. So your top level would be your user, your next level would be your ID and your username. And then if you had any subsequent nested entities that you were trying to grab with your query, those would all just be broken down into a tree structure. So what this allows us to do is actually break apart that query, or break apart the tree, and then formulate a SQL statement based off of that tree that we get. So we would know if, based on our entity get all, if we had user as our top level and then ID and username, we would be forming a very simple select statement of select ID username from the user table, right? So as long as that, if that nests down even further, you would just build a more complex nest statement with inner joins or left joins or whatever else you needed, right? So HotChocolate handles mutations a little different than queries. The best practice that they recommend for mutations is to have a little bit less of a generic intake. They want things to be more one-to-one. So when it comes to the mutations, you tend to have to write more specific add user, add users. You can't really get away with making things a little more dynamic. And at first, that's a little tough because it seems like you have to write a lot of boilerplate code. But when you really dive into it, it makes a lot of sense because it gives you a very, very powerful way of handling errors specific to whatever call you're working with. So to answer your question earlier, you were asking how you would actually handle exceptions in mutations or queries. What you can actually do is HotChocolate recommends that if you notice here in your add user payload, HotChocolate actually recommends that you have your user payload at the end here on where it says return new add user payload and you're passing in a result. It actually recommends that you take either the entity you're trying to return or it take backs whatever exception you're trying to handle. So what that lets you do is you can pretty much define what your exception is. So anywhere across the process, you can specifically state what your exception was. And then on your on the IDE, if you're requesting, you'll actually be able to see back on your response body. You'll be able to see back what that exception was, and you can do whatever you want to on your client, or you could handle it on your GraphQL client if you wanted to. There's a lot of things you could do with it. It gives you a lot of customability, basically. So the next one is how do abstract types actually work in HotChocolate? So if we saw on our schema earlier, we noticed we had a type user that then implemented a type entity, right? So in our actual C# code, what this looks like is we have our user here, we have it inheriting from our entity class, and then down here, we're actually defining our abstract class for entity, and we're defining these fields here. So at this point, HotChocolate actually creates your schema for you. So whatever we saw back earlier on our slides about GraphQL, HotChocolate is actually generating all of that for you. So this public class user here that inherits from entity, this is actually being translated into a type user that implements entity. And then down here lower, this public abstract class entity is what's actually being interpreted on our schema as an interface of entity. So next, we're going to be doing a demo. But if anybody had any questions on anything specific to HotChocolate, the floor is definitely open. Okay. So we'll go ahead and let me go ahead and slide over. So what we're looking at over here, this is Banana Cake Pop. So this is the Chili Cream Platform's IDE for passing in queries or mutations to your GraphQL client. So the first thing we're looking at here is this is our query for an entity get all. And if you notice, this is the exact same snippet that we saw earlier on our GraphQL slide for queries, the query type. So we know we have our ... for on user. So this lets us know we're trying to run the entity get all operation. We're trying to return back our type user, and we want to grab the ID and the username from that. So if we go ahead and we actually run that, one second. So we'll see if we actually run that. We'll see that we get back our results here. So we have our entity get all, and we see that we got back all the results of type user. Now, something really, really cool about Banana Cake Pop is you can actually go over to schema reference, and it will show you all your query operations. And you can actually break down here based on your query operations or your mutation operations, and you can dive down as far as you want to go. So for query, you see you have an entity get all. You could click, what is entity? And it'll actually take you to the 5 types that make up the entity abstract type. And you can click as far as you want to go, and it'll take you all the way to the base level, which lets you know that this is date type and it is of a scalar type. On your schema definition over here, you can actually see the entire schema that HotChocolate generates for you. So if we scroll down, this snippet should look familiar to you because this is the one that you saw earlier for the actual schema. So we see what queries types we have access to. We also see what mutation types we have access to, and you see the user type that we just ran an operation against. So you could actually, because these implement entity on all 4 of these, you could request whatever you wanted out of that entity get all, because they all implement this entity abstract type. So you could get back type user if you wanted to, type user role, role action, user type. As you can see, this is a simple example, but it's very powerful and you can do a lot of things with it. If we scroll down further on our schema, we'll actually see what our add user input looks like, and we'll also see what our payload is. So this lets us know that when we are getting back an add user payload, we're returning back a type user. And if we were curious what type user was, scroll up and we see we have our type user defined up here at the top. So the next thing I want to show you is now that we've run a get all operation and we've gotten an ID back over here, I want to show you a more specific implementation that you can do. So we have over here, we actually have our entity get by ID, right? So we're going to take our ID over here and we're going to actually pass our ID through here. And you'll notice that we only receive back a single result. So this is an example of actually passing in an input into your query operation and returning back a specific result that you wanted to. So the next thing I want to show you with the demo is what a mutation type looks like. So we have our add user defined here. We have our username that we wish to pass through. And this down here, this is our actual user payload that we're going to be receiving back. So this lets us know that we are going to be adding this user to our database, and we're going to be returning back a type user, and we want to have the username value passed back in or returned back that we actually created, right? So if we go ahead and we create this, we'll notice that we've now added a user. We've received back our username, which is the one we added. And if we navigate back to our get all operation, you'll see that we now have a record here that we just added. Now, a good thing to know about this is if you want to get a more complex query going, you can actually do user, and you can actually get back user type. So user type would be a nested entity on the user object type. Now, the important thing to know here is when we inserted our record prior, we did not actually insert a user type for this record. So because we did not insert a user type for that record, when we try to select data here and we specifically ask to have a user type back, we do not expect to receive a result back for our most previous record we inserted. That's because whenever we're doing these sort of operations, we're actually doing a left join. And because there's no user type for the record we just inserted, we don't actually receive data back. So that is everything for the demo. I think we can go back to the slide. And the last thing we'll have is just if there are any questions. Yep. Yeah, so Jonathan asked, when you say GraphQL client, are you referring to the client, browser, mobile, et cetera, that is making the request? So typically when we say GraphQL client, we're actually referring to HotChocolate. If we say just client, we're referring to whatever front end is sending you a query or a mutation. So the actual front end would be sending you the queries that you are seeing over here. So this would actually come from whatever front end application was connected to your GraphQL client. Does that make sense? Sweet.
Can you go back to, I think it was the third tab?
Third tab?
Yeah. One has to not in the first tab.
Oh, in the playground? Sure.
Well, the one I just passed in.
Oh, the one that was passing in the ID? Yep. You want to see the C# side of this? Absolutely.
Or that example.
Yes. Anything in particular you're looking for?
No, it's just some actual structures of breaking down. So nothing, no actual one.
No, so yeah, so what you're actually doing is it's actually over here on your, when we're building our query template, what we're actually doing is we're taking this iResolver context, which comes in with our tree structure, and this ID actually comes in as a separate parameter.
Yeah.
So what you're doing is, since you're calling your entity get by ID, you're using your resolver context to build out your standard select statement. And then because we have a parameter here, we're then building out a where clause and then passing in whatever our ID is. And this is a relatively simple example, but you can actually have an input type coming in for your same as you saw for the mutations where you had a defined input type coming in. You can actually do that on your queries as well. And you could pass in multiple fields if you needed to. If you wanted to have, you know, say a where statement with multiple ands or ors, you could define that if you wanted to. Yes.
Quick question. So really cool stuff. A really great demo. Appreciate it. So if your C# code is, thank you for the mic. Your C# code is building out the schema and this HotChocolate front end, right? That you're seeing, right? Is there any way to have a schema in GraphQL and scaffold out your backend C#, or is it only unidirectional when it comes to C# to your schema? Is there a
Sorry, ask that again. I didn't hear.
Yeah, no problem. So sorry, long day of work and talk. All right.
No, you're good. You're good.
So your backend C# code is building out the schema that you're seeing in HotChocolate, right?
Yes.
Is there any way to scaffold out C# code with the schema, writing it beforehand to remain, somewhat language agnostic?
Yeah. So as far I'm not entirely sure, but as far as I know, I think that's what Strawberry Shake Pop. Chili Cream has. They love to go.
I
with
love the names.
Yeah, they love to go with
Electric.
those names. Yeah, and I think that's what Strawberry. I think that's what Strawberry Shake was supposed to do. I think. I'm not entirely sure on that.
All right, great, thanks. I'll check it out. Appreciate it.
It's pretty robust, honestly. So I would imagine any question you have is probably answered. Realistically. Is there anything else anyone has?
There's a question in the chat.
There's a question in the chat. Okay. Yeah, so it looks like Jonathan asked, can you modify the HTTP status code of the response? So the status codes can get a little funky with GraphQL. The biggest issue that comes from it is if you read online, depending on what source you get to, they'll complain a lot about the error handling, and they'll complain that GraphQL only returns back a status 200 no matter what happens. That's not entirely true. If you try to send through something, like I believe if I try to just remove this and just like run through, you'll get back errors, right? So you're actually getting a status 400 here, right? Even though the internet will try to tell you that you receive back a status 200 regardless, it's not necessarily true. That's generally why when I was answering the question earlier, you want to have the actual error handling object in your payload so you can handle whatever exception comes back. That answer your question at all, Jonathan? Okay, cool. Do we have any other questions from anyone? Oh, let's see, real quick. Can we see the Dapper code that translates the query? I'm not making the connection between the payload and the DB query. Yeah, which query exactly would you like to see? Do you want to see the get all, or do you want to see the get by ID? Okay. So the build query template is what actually breaks down. The build query template is what actually breaks down our iResolver context that comes through. So the selection set node up here that you see is actually something that comes from HotChocolate itself. So if you look at the prior here, we're actually grabbing our top level here. So this context.selection would be a representation of our entire tree structure. And then we're passing that through on our build query template. So we have two different build query templates here, and one of them, if you were like actually doing this on like an enterprise level, you would want to handle your create where a little differently. For the sake of the demo, we have it just actually creating a by ID, but you could definitely make that more dynamic for that. So what we have here for our build query, we're actually having to break it down, and you're having to loop through your selections. So this iSelection node up here that you're doing, the first thing you're needing to do is you're needing to get the type. So getting your type up here would be actually grabbing, if you see your query up here, that get type would be grabbing your user up here at the top.
Oh.
Yeah, that's one of the most important things we have to do. Because as you can see here, you really don't have any way of knowing when you're trying to do this generic, you have no way of knowing what type you're actually working with. So that's why using the GraphQL fragments was so appealing when we were doing this, because this gives you a hard entry point into exactly which table you're trying to request data from. So when you're grabbing your type here, this lets us know our table is going to be of user, right? And a lot of this won't make a whole lot of sense because these are GraphQL, or sorry, these are HotChocolate specific terms for like the inline fragment and the like the field node and the inline fragment and the selection set. These are all part of the tree structure I was referring to. But for the most part, we're grabbing the type so we know it's user. We're setting that as our from table. And then what we're doing here is we're actually looping through. And these select columns here, these are the initial columns we're actually using to build out our initial select statement. So these right here would be our top level select statement. So this would get us ID and this would get us username. If you had a more complex query such as this, where you have ID, username, and then you're also grabbing a nested object in here with ID and type, you would actually go a step further and you would have to actually go down here and you would have to run the other code we have here to actually build out a join operation. So when we come down to our join operation, it's very, very similar to the code up here that we see for our building the query. The only difference with the join query is we're actually going to recurse through as many times as we need to build out however many join statements we need.
Okay. And so somewhere, I guess your table names are actually matching the entity names so that when Dapper is actually running a select statement for users, it's going against a user table?
Yeah, so the thing, for the sake of the actual project that we did here on a small scale, we made sure our entity names were a one-to-one with our database table. But if you wanted to actually enforce naming, you could add attribute tags. You could add attribute tags up here to hard define like what exactly your table names were. And then what we would do is we would actually use reflection to get the table name so we would know exactly what it is.
So like the data, kind of like those data annotations is what we would use here.
Yeah, you would use for C# it's attribute tags at the top.
Okay.
Yeah,
Okay.
you'll notice here, like this would be an attribute right here, this foreign key, how we're defining this. You would have an attribute up here that would actually define what your table name was.
Okay. Okay. I'm following now.
Does that answer your question?
Yes. Thank you for showing me this because I was surely missing the connection between the payload request and the connection to the database.
Yeah, absolutely. So the whole point when we were doing this is obviously you want your, just like anything, you wanted your queries to be as clean as possible and then to move your code away to, wherever else. Okay. So Jonathan asked, does HotChocolate handle schema stitching or do you need another tool for that? So I'm not entirely sure how schema stitching works with HotChocolate. We didn't explore far enough in that. I just know that schema stitching is a very popular thing to do with GraphQL in general. It does, yeah. Frank says it does. Does that answer your question, Jonathan? Sweet. Any more questions for anyone?
Yeah, so similar, can we see sort of the magic that bootstraps the front end of this? Like how is it surfacing that metadata to show the schema, and how are you actually connecting to the C# service, right? Like, is there an endpoint? I mean, there has to be an endpoint somewhere, right?
Yeah, so GraphQL, one of the big appeals of it is it's actually a single endpoint, right? So anyone who's written anything with a REST API, you're writing a million endpoints for whatever you need. So GraphQL actually has a single endpoint you're hitting. So are you more so asking what does a front end look like when it's trying to send, or? No, where's the oh, yeah, so right. So our endpoint is actually this, but if you had this deployed out, it would be whatever your deployed endpoint is, as far as I know. Yeah, but like in project, how when I hit that URL, what's the first thing that's in? Oh, yeah. So when you're actually hitting the URL based on the query or mutation you're passing through, that's what actually determines where you're navigating to. It's all a single endpoint. You're just hitting an endpoint and you're passing through a query or mutation. Yeah.
HotChocolate, you're defining all your schemas and then HotChocolate builds out
Yeah.
the endpoint.
Yep, for you. Yeah, your startup class honestly looks very, very small. You're just adding in some really basic things here. So all of these types are going to be your GraphQL types that you're using. These query types and mutation types. If you just have a simple project, it will just be a query or a mutation. But if you have a more sophisticated implementation, you'll actually break these query types out into more specific things. So query, not so much, because you can get away being pretty generic with it, but the mutations, you're going to actually have probably several files for each mutation. So you'd have a user mutation, a user role mutation, and you would define that here as well. And this is, by the way, this is 6.0. So it's doesn't have startup. It's just a program.cs. It's the minimal API. Yes, yeah, that's the big takeaway. You don't have a specific controller that you're actually like routing to per se. You have your query and your mutation, and you're defining whatever that type is here. But you can split these types up into multiple things if you wanted to. We don't have an example here on this project, but you could have as many mutation types as you wanted to, and you could define that here in your startup. Yeah. It does seem like magic at first. Yeah, I'm with you. Were there any other questions? Did not get a chance to look at subscriptions, no, but HotChocolate has some documentation on subscriptions. Yep. And I saw HotChocolate actually has some pretty good documentation. Their implementation actually for queries actually uses Entity Framework. We didn't actually use Entity Framework for the queries because it seemed kind of to defeat the concept of not overfetching or underfetching. But their mutations with Entity Framework in GraphQL work very, very well. But for this specific example here, we actually use Dapper for mutations. So Jonathan asked, does HotChocolate offer any ability to define data level security, or do you need to roll that yourself? We didn't go honestly too far into security with HotChocolate. I wouldn't be able to give you a good answer on HotChocolate. Yeah. Mm-hmm. Any other questions anyone has? Cool. So there's also, if anybody wants this, we actually have a link at the end that will give you the URL for the repository. If anybody wanted to go through and look at the code, do whatever you wanted with it. I don't know, ping me directly, tell me you hate it, you know, whatever you want to do. But it's definitely there if anybody wants it. Say when? We could, yeah, absolutely. Yeah, absolutely. We could put it on there. Absolutely. Absolutely, yeah. We good? Cool. Thank you, Jonathan. I think we're good. Sweet. All right. Well, I appreciate everybody's time. Thank you.